Since we already know a lot of reactions that we can do with alkyl halides, let's see how we can turn an alcohol into an alkyl halide with HX. Okay, so I have an alcohol, and I react it with sodium chloride. So I want the chloride to displace the OH to make an alkyl halide. This is another place where we can use pKs to help tell us what's going to happen. So I have chloride here, which is the conjugate base of HCl. And over here I have hydroxide, which is the conjugate base of water. HCl has a pK of about -7, water has a pK of around 15. So this reaction lies almost completely the opposite direction. The chloride is much more stable on its own than a hydroxide, and maybe that's fairly obvious because our reagent here is sodium chloride, or salt, which we eat or we swim in salt water or whatever. And the byproduct over on this side is sodium hydroxide, which is a very strong base. If you touch it, it will burn your skin and start to melt layers of your skin off. So that reaction won't happen. Now if I perform this reaction in acid instead of the salt solution that I used in the last one, the first thing that happens is this hydroxide gets protonated, pushing the electron pair onto bromide. Make this intermediate, which now has a good enough leaving group that the bromide can come in and attack here. Water leaves to form your product plus water. The difference between these two reactions is up here I have a bad leaving group. Here I have a good leaving group. Now it's important to note that HI is the most reactive. It's the best nucleophile. I- is of the acids, which is better than HBr, which is better than HCl. In fact, HCl won't even do this reaction. It's just not strong enough, not reactive enough. And again, what happens if we have a more substituted alcohol? So look at the same reaction. The first thing is going to actually be the same. The first thing that's going to happen is we're going to protonate our alcohol. That can make it a better leaving group. Now, however, this is too bulky for a SN2 type mechanism, but I would have good carbocation stability if this water leaves, because I'll have a tertiary carbocation. So in this case, water leaves. I've got a tertiary carbocation plus water, and now my bromide attacks. So now I've got a negative charge here, a positive charge there, and I can make a new alkyl halide. Now this one will work with HI, HBr, or HCl. Let me ask you a question, why? So pause the video and think about it for a second, and then start up again and see if you're right. Well, here the strength of the nucleophile doesn't matter, because it's following an SN1 type mechanism. And the rate determining step was back here before the nucleophile even entered. So whether it's chloride, bromide, iodide doesn't make any difference because this is highly reactive. In the next section, we'll look at other conversions to alkyl halides using some other new reagents. So here I'll take my alcohol, I'm going to react it with SOCl2, which is called thionyl chloride, and one equivalent of pyridine. That one equivalent is going to be important at the end of the mechanism. So in a lot of ways, this is very similar to the phosphorus oxychloride mechanism. So the first thing you need to be able to do is draw what SOCl2 looks like, or what thionyl chloride looks like. So why don't you pause the video and try and see if you can draw the Lewis structure of it first, and then come back and see if you're right. So sulfur makes 4 or 6 bonds. It's got a bond to oxygen, and it's got 2 chlorines. That would only be 3. And oxygen would only have 1. So SOCl2 has 2 bonds to oxygen, and then 2 chlorides. Now once again, a lot like phosphorus oxychloride, you've got a delta minus on each of your chlorines and your oxygen, which gives a delta plus on sulfur. So again, I would challenge you to pause the video, see if you can draw the first step of the mechanism, and maybe even the second step, and then come back and see if you're right or not. Just like with phosphorus oxychloride, the oxygen has electrons, the sulfur wants them. The sulfur has good leaving groups in the halogens, so one of the chlorides leaves to make our intermediate. Our pyridine comes along and deprotonates our intermediate to make a second intermediate. And now we've used everything that's in solution except for one thing that left right back here, and that's that there's another chloride around. So that chloride now, because I don't have excess pyridine, I don't have another pyridine to come in and take off a proton, chloride, it's a good nucleophile, but not a base. The chloride can come in and drive off the SO2Cl. And I've got SO2Cl, and this is a good leaving group. So the whole point of these, the phosphorus oxychloride and the thionyl chloride reactions, is to try to make something that's going to make that alcohol a good leaving group. Now if we want to do that with a bromine, we can do the same kind of thing. I'll draw the reaction the same otherwise. Except now, instead of thionyl chloride, we use PBr3, phosphorus tribromide, and one equivalent of pyridine. PBr3 is a bit easier to draw. Phosphorus has 5 electrons, so there's a lone pair on phosphorus. You might want to try drawing this mechanism on your own again, because it's, again, very similar. This is one of the things I love about organic chemistry, is while some people think that organic chemistry is a lot about memorizing, there's a lot more about it that's about logic. So if you're using our areas, 5 main rules, we can answer so many questions without having to memorize everything. So here's a reaction that we've never seen before. You know who has electrons and who wants them, and see if you can follow through and draw out the reaction. So the OH has electrons, phosphorus wants them. Once it attacks there, a bromide leaves because they make good leaving groups. To make an intermediate. Which pyridine then comes by, deprotonates that to make it neutral. Remember, the whole idea of this is to activate the oxygen to make it a good leaving group. The bromide that left earlier can come back because I don't have excess pyridine around. Extra bromide comes back and drives off my OPBr2.